The genetic code is comprised of mRNA and its base pairs that call for amino acids, which then form proteins. 3 base pair of mRNA form a codon. 61 codons code for 20 amino acids. The genetic code is degenerate and redundant in that more than one codon can call for one amino acid. The third base of the codon has the ability to wobble with relaxed hydrogen bonding to the first position of the anticodon on the tRNA. This allows for the tRNA with the same amino acid to bind with more than one codon. mRNA is read from 5' to 3', with the start codon as AUG coding for the amino acid methionine. First is tRNA charging. This is where tRNA is going to bind with the amino acid at the 3' site of the tRNA. This tRNA has an anticodon that reads from the 5' to 3' direction as CAU, and it's going to bind with the codon of the mRNA, AUG. Next is initiation. The small ribosomal subunit is going to bind to the mRNA. Then, initiation factor 3, IF3, is going to bind with the small ribosomal subunit. This is going to prevent our large ribosomal subunit from attaching during initiation. Next, our tRNA is going to bind to our mRNA at the start codon, and also other initiation factors are also going to bind. Then, the initiation factors are going to be removed, and then the large ribosomal subunit is going to attach. Now, this tRNA is in the P site, or the peptidyl site. This tRNA is going to become a complex with elongation factor 2, EF2, and GTP. This starts the elongation process. Now, our next tRNA, with its amino acid, which is called for by our codon, is going to enter in the A site, which is the amino acyl site. Now, our GTP is going to be converted to GDP, an inorganic phosphate. This is going to cause the EF2 and GDP, an inorganic phosphate, to release. Now, a peptide bond is going to form between the two amino acids. Then, the ribosomal subunit is going to move towards the 3' end. Now, our start tRNA is in the exit site, or E site, and it is going to leave. Now, our second tRNA is in the P site. So now this tRNA is going to make a complex with elongation factor 2 and GTP. The process will repeat again with the addition of another amino acid and the formation of a new peptide bond. Now, our second tRNA has already left from the E site as our ribosomal subunit has moved down the mRNA, and now our polypeptide has formed and termination will begin. The ribosomal subunit has now hit a stop codon, UAG. The stop codon could either be UAA, UAG, or UGA. The stop codon does not code for an amino acid, but instead it's going to call for a release factor. The release factor does not have an anticodon and binds in the A site. The polypeptide is released from the tRNA, and the small and large ribosomal subunit released from the mRNA along with the tRNA.